All right, so I'm going to work through how to get the offsets and signatures for all these random functions that are used in the bhoptimer. A lot of this stuff is not exported by the source engine or anything like that, so we got to use all this game data to get it. So we're going to use Ghidra. Check it out here, it's pretty cool. And also I have all these server.dll, server.so files from Asherkin's public bins folder. It's pretty useful. I'll link these in the description, of course. I dropped them in here, so I'm going to go ahead and create a Ghidra project with all the folders and files so we can import them and find them easier. Let's create a new project. We'll name it Source Stuff. Pretty simple. CSS, CSGO. Go back to my binaries folder because I already dropped all these in there. It's going to go ahead and import those, parsing all the loaded libraries and such. This is not decompiling it yet. Decompiling is going to take a long ass time. Unfortunately, that's what happens. All right, imported those. Let's go to CSS, drop these in there. I'm not going to even be checking the server.so files for this because honestly, I won't need to. I mean, they're all using generally these kind of symbols here. They do export it for the CSS servers. They won't for the CSGO ones, but I'm not even going to bother finding the signatures because it's going to be the same as with Windows, just, you're using the server Linux binaries. So we're going to go ahead and check out these stuff real quick. I'm going to show a quick one real quick for all the CSS ones because they use VTable offsets that are easy to find, and we're going to just use this link. So over here, I'm going to load up the server binary. We're looking for that. I wonder if just copying and pasting it with the class, yep, okay. So 438, 439, yep, that's right. Mac and Linux use +1 for the offsets, generally because of some class destructor thing, adding 1 to it, yada yada. We'll go ahead and check the is spawn point valid also that's used. Is spawn point valid? See, game rules never really changes, so 76, 77, Windows, Linux. That's correct. It doesn't really change, so between CSGO and C-Strike, that is. So it's just +1 and hope it works pretty much, which it does, thankfully. Finding that would kind of just be more pain. UpdateStepSound, we'll find that real quick. Uh, 358, 359, all right. All right, so now we are on to the actual signatures, and I'm gonna open up Ghidra and just start it decompiling. It's gonna take a while for, all the strings to be found, all the functions to be analyzed, to figure out where function borders are and such. So while that's decompiling, it's just gonna be a fast-forwarded video. All right, it's been about 13 IRL minutes for me. PDB warning, whatever. So we're going to go into the first offsets we should find. So for CSGO, we have GetPlayerMaxSpeed. Our search string is this SFUI thing. It's used in one of the functions right before. Let's see what it says to find yada yada, and then we go to the next function, and that's GetPlayerMaxSpeed. And then once we find GetPlayerMaxSpeed, we will calculate the VTable offset. So it looks like both of these references are the same function. Easy enough. I'm going to use my control down, I think that's right. And this should be GetPlayerMaxSpeed. I'm going to go with it is because of Weapon Shield, and I've been looking at that when I was double checking this previously. Shit, let me double check over here real quick too to make sure it's used in the right place in the right way. All right, so I'm going to go with yes. Let's double check param1. Param1 I think is this pointer, which is the player. So that is probably GetPlayerMaxSpeed. To find the next function, then let's go calculate the VTable offset to see if this is even the right thing, even though it has fast call and it's generally going to be a this call. So we're going to take this address, clear this up, make sure we're on hex in our calculator. Just going to scroll to the top of the VTable, grab the address at the top, and then subtract. And that should be the top right there, minus that. Divide by 4 because ints are 4 bytes, 505. 505, so yep, we have the correct offset. Surprisingly enough, this is actually the correct function. I'm surprised, not gonna lie. Linux and Mac are generally +1 on the offset because of some VTable destructor things, so yada yada. So that's correct, we found that. Is spawn point valid? Not gonna bother with that. That should be the same as the CSS one here that we found, but +1, and that works because cgame rules doesn't really update. We can't find this yet until we find BotAddCommand. We'll go ahead and look for UpdateStepSound, so we will copy this search string, pull up Ghidra again. Can't find specific step sound, one reference. What does it say? So we find play step sound, and then we grab the VTable that play step sound is, and update step sound is the function right before. Simple enough. Reference is data reference. Okay. So this function right here should be update step sound. We'll just take a look at it anyway. It's right anyway, so I'm not going to really confirm it. We'll just go ahead and check the VTable is correct though, or the offset from the VTable matches because it hasn't changed since I last updated the offsets. Just checking that, you know, this is the right way. So 660 hexadecimal, of course, divided by 4, 408. 408, that is correct. Linux +1 generally. So we have that. We have all the offsets except for weapon type unknown. So we'll go ahead and look at the signatures. And we will start at BotAddCommand so we can also find weapon type unknown. So BotAddCommand, blah, blah, blah. Use the search string. And what does this find? This finds the function. Okay, so right here is BotAddCommand. And let's find weapon type unknown first. So weapon type unknown, the weapon type parameter is param4, generally the fourth parameter of the function. And right here we see OX13. It's checking if param4 is set to weapon type unknown. And if it is, it'll just, I think, pick a random weapon type or something. I can't remember. In this function here, it'll just use a random param type. But anyway, so let's check 13. And the decimal is 19, so that is correct for this. And it does not change between the operating system. So we have BotAddCommand, we have weapon type unknown. Let's generate the signature for this real quick. Go to our script manager and use our makesig function that I'll have to link to in the description. I didn't have any sort of install thing for that. So we have this right here, which is the signature for BotAddCommand. We'll paste that to see if it changes. It does not, so it's the same. So now we will go to MaintainBotQuota. So the search string for this is nobots, -nobots, which is a command line argument for the server. It's used in a couple places, but we'll just check to see. Not this one. We're looking for something that checks the player count at the beginning. This one is it because of, I mean, just look at the source code, honestly. This is it though. So this is it. These are some get player count checking this. I think it's checking some engine function result. And this is the player count. And if there's no players, MaintainBotQuota just bails early. So we have MaintainBotQuota. I'll go ahead and just rename it anyway. Now we'll go back to our makesig, start a function. Now we have this. We'll paste it and see if it differs. It should be the same. Yep, should be the same. Right, so now we have BotAddCommand, MaintainBotQuota, and we'll have PhysicsCheckForEntityUntouch and DoAnimationEvent to check now. All right, so for CCS player DoAnimationEvent, we're going to be searching for silencer detach, and it does not go directly to the function. but right near it, let's click around so it'll go to it in the disassembly. Maybe, hopefully it will. I mean, should I guess not? Okay, well, that's tough luck. Silencer detach right there. And I believe it's going to be this function here. DoAnimationEvent has 2 parameters to it. So let's just take a look at this. Yep. So right here it's checking some nade throw thing, and then it'll do some random stuff. And if not, it'll call the some animation state VTable thing for a DoAnimationEvent also. So this right here is CSS DoAnimationEvent. Go ahead and rename that. Then we'll calculate the signature. Start a function, yes. Copy that. We'll just paste and compare again. None of these have changed since I last made them. All right, well, that's the same. So all these first 3 are done. We'll check for this now. So we have to find the search string to find PhysicsRemoveToucher. And then one of the functions that call PhysicsRemoveToucher is what we're looking for. We'll go back to the one with 2 references, which I believe is this. It might be this. Hard to say. We'll just calculate the offset for this one too, with the signature. See if it's matching. Okay, well that looks like it's it. It was a bit of a runaround to find that. You know, I'm not comparing with the source code. So this one is it. We'll go back and take a look at what this was found through. So we'll start at the beginning. So we had this. We looked at maybe 1. Then we looked at the references to maybe 1. And it was a function with 1 argument. I had the argument count mixed up, so I was confusing it with PhysicsRemoveToucher. So anyways, this signature matches just found with IDA, so it's slightly different though. These OX2As are asterisks, which are an any symbol for these SourceMod signatures stuff, yada yada. So we have all of these now. And now we will go on to the C-strike one, all these VTable offsets. I think I already went through in the VTable Dumper. So now I'll just save this and open up server.dll and wait for it to be analyzed so I can, you know, further progress through this. Already that's done decompiling or analyzing, I should say. Now we have the CSS Linux binary. We're going to go ahead and look for the signatures. We don't need any of the offsets. We can find weapon type unknown and BotAddCommand once again, which we will start with actually. Knock out 2 birds, 1 stone. 1 function reference, that is what we are looking for. So this is BotAddCommand. I'm going to go ahead and mark that as such. So param4 is not as it's not referenced as quickly, I guess, for the weapon type unknowns. We're going to go ahead and look at the references to find calls to this, and right there, found it on the first reference, 9. 9 for weapon type unknown, easy enough. So we'll go back here and now generate the signature. Start a function, yes. Now we have our big ass signature. Let's try to copy the line and not all these random extra bytes. And nothing's changed, so I know that's correct. Next we'll look at -nobots for MaintainBotQuota. We already went through this where it's think I'll check the second function first. That's what it was last time. I think that might be it because of that. I'll check the other ones real quick too, though, to compare. Nope, that's not going to be it. And also that's not going to be it because this is create fake client. You can tell because of this string right here. So let's go back and back again. And here we go, MaintainBotQuota. Yada yada, player count check, yada yada, engine call result. So we have that. We will do the make sig function or Python command file, yada yada. Compare the result. Yep, that's correct. Now we have to find this again and also DoAnimationEvent. So for DoAnimationEvent, CCS player DoAnimationEvent, we will look for a call reference. So right now we have reload effect. That's definitely not it. Go back. Reload effect right there. And should be this one. This is some user message creation function and some other stuff where we get some value. And then this is the end of the user message where it sends. And then this should be DoAnimationEvent. This param2 is the animation event type. I believe param100 is the this pointer, which is the player in this case. So param2 yada yada. This is it though. That's the gist of all that. Rename it and let's do the SigMaker again. And we'll paste to compare. None of these have changed since I first wrote all this down. It looks like that 1 byte is now a 2A. I'll leave that unchanged for now. Maybe I'll come back. Fuck it, we'll save that as is. So now we have to look for PhysicsUntouch again. That's kind of a pain to find. Don't really like finding this one. So we will start with this. I don't think that's it. Let's go over here. All right, so this should be PhysicsRemoveToucher because it has 2 parameters. Now we'll find the reference to this. All right, and the 1 parameter here makes this PhysicsRemove or PhysicsCheckForEntityUntouch. So now we will calculate the sig for this also. This might slightly differ because of this signature at the top was found with IDA, so we have all these starting bytes correct up till here where sig or make sig.py has a lot of asterisks and a little bit more, so the same signature at the end of the day though, it'll find the same thing. And so we have all that, we have that, we found MaintainBotQuota, I believe. Checked all of these, and yep, that's it. That's finding all the signatures and offsets.